So today we are moving on to the last section for the statistics chapter. We're looking at standard scores and we're finding percentages with normally distributed values. So in a standard normal distribution, the mean is always 0 and a standard deviation is always 1 away. A z-score helps us find the area under a curve when it's not exactly a nice standard deviation away. So if it's like 0.3 away instead of 1. When we're given a sample mean with x bar, that's how you read that, and a standard deviation s, the z-score is z equals x minus x bar over s. So x is the data value you care about, and x bar is the mean, s is the standard deviation. If a z-score comes out negative, it just means that that is on the left side of the mean. And if it's positive, it's on the right side. So number 1 wants me to find, it tells me that the average height of a man is 69.3 inches and the standard deviation is 2.8 inches. It wants me to find the z-score for a man who is 6 feet 4 inches tall and to describe what that tells us. So the first thing is I'm going to label what my things are. So the mean height is x bar, the standard deviation is s, and the specific man we're looking at is our x. But the average height and the standard deviation are both given to me in inches, so I need to turn his height into full inches. So I'm going to do 6 times 12 because there's 12 inches in a foot, and add that back to the other 4 inches he has. Is anyone else having issues seeing my screen?
Yeah, I was having issues for the first few minutes, but I think it was like...
Okay. So does anyone have a total number of inches for how tall that guy is? So 76, this is going to be my x, and I want to plug into that formula that I highlighted earlier. So 76 minus the 69.3, and then I am dividing by, where'd it go? 2.8. So remember, if I'm typing this straight into the calculator, I want to remember to put the top part in parentheses, otherwise it will just divide the 69.3 instead of what you get after you subtract.
So how'd you get the 6 and the 12?
Okay, so it told us the guy was 6 feet 4 inches tall. So I was trying to turn it completely into inches. So remember, there are 12 inches in a foot. So I took the 6 times 12. Yeah.
Okay, sorry. I couldn't hear anything, and I kept leaving and rejoining, so
That's fine.
It finally worked.
That's good. So this gets us 2.39. And what this means is his height is 2.39 standard deviations above the mean. So this means he is really tall compared to most men. Okay. Number 2 tells me there's two main standardized college entrance exams, the ACT and the SAT. They have different scoring scales, so you can't exactly compare what someone gets on an ACT to what someone gets on an SAT. But you can compare their standard deviations because those are kind of measuring it on the same scale. It tells me that 1 year the ACT had a mean score of 21.2 and a standard deviation of 5.1. The same year, the SAT had a mean score of 1498 with a standard deviation of 347. It says, suppose that a scholarship committee is considering two students, one who scored 26 on the ACT and another student who scored 1800 on the SAT. Which score is better? So, first thing I want to do is I want to go ahead and find my z-score for the ACT. So my x bar is the 21.2, my s is the 5.1, and the score I care about is the 26. So I'm going to go ahead and plug that into the formula. This one is 0.94. And then I want to go ahead and do the same thing for the SAT. So I'm going to do this in a different color when I go write out my variables so it's clear. This one has a mean score of 1498, so that's my x bar. The standard deviation is the s, and the score on the test is the x. So then I want to go ahead and plug it in. I have 1800 minus the 1498 divided by 347.
So is the z-score basically telling us here that, like in this case, the ACT score is 94% of one standard deviation away from the mean, and then on the SAT it's 87% of one standard deviation away?
Yes.
Okay.
So I want to see which one is closer to 1 to decide which one is the better score. So the student who took the ACT scored higher. Okay. The next thing we're going to look at is this chart, which will give us the area under the curve for each standard deviation. The way this chart works is it gives me the areas to the left of the data value. So if I think of a standard curve like this, if I had a data value here, it's giving all the area covered by the stuff on the left. Okay. So what number 3 wants me to do is it wants me to find the area under the standard normal distribution between the given data points for A, B, and C. It's asking between 1.5 and 2.2. So before I even go ahead and look at how to find that, if I know my chart is giving me data values to the left, say this is 1.5 and this is 2.2. So for 1.5, it's giving me everything in orange. And for 2.2, it's going to give me everything in green. Notice if I care about in between those data values, I only care about this portion right here, not the overlapping piece. So to get rid of that, I would subtract the orange piece away, which was the 1.5. So when it asks me to find the area between two values, I want to subtract the areas. So the first thing I want to do is I want to go ahead and use this chart to go find my two areas. 1.5, these are the z-scores are the numbers in the gray columns, and the areas are the ones in the white columns to the right. So if I'm looking for 1.5, it is right here. My area is 0.9332. And then I want to do the same thing for 2.2, which is 0.9861. And then when I'm subtracting the areas, I always subtract the smaller one from the larger one. So I'm going to do the 0.9861 and subtract the 0.9339, yeah, 33.2. Yep, this gives me 0.0529. So what this is saying is if I think of this as a percent, there's about 5% of my data values that are going to fall between that range. So
I have a couple questions. So when you said to subtract the areas, well, how did you do that again?
I took the larger of the two numbers and put that in front and then subtracted the smaller one. Or how did I get those? Yeah.
You subtracted the 2.2 away from 1.5?
No. So what I did was I took the 1.5 and the 2.2 and I looked them up on this chart. So the 1.5 was right here. And then I took that area that was to the right of it, the 0.9332. And then I did the same thing for the 2.2, which gave me the 0.9861. And then I took those two numbers that I found from the area column and subtracted.
Okay, thank you.
Any other questions here? So the next one wants me to find it between negative 0.6 and negative 1.4. So if I look over here, I want to look for negative 0.6, which is 0.2743. And then negative 1.4 is here, which is 0.0808. So then I want to take the larger number, which is the 0.2743, and subtract the 0.0808. Which gets us 0.1935. Okay, and then I want to do the same thing for C. So the first Z value is positive 1.5. That is 0.9332. And then the second one is negative 1.8, which is 0.0359. And then I want to go ahead and subtract these. So I have 0.9332 minus 0.0359. which gives us 0.8973. Okay, so the next one we're looking at wants the area under the right for number 4. So if I think about this one, if I have something like this, it gives me the data values normally over here, but the ones I care about are on that empty side. So if everything under the curve is 1, I just subtract away to get the area. Okay, so what I want to do here is I again want to go find this area on the chart. So I'm looking at the chart from the previous page, and I'm looking up 1.7. When I do that, it gives me 0.9554. So what I want to do is I want to take this and subtract from 1.
Era, do you mind moving your paper back down, please?
Oh, sorry, I didn't even realize I hit it. I got like a big sweater on and it just kind of caught on the sleeve.
Thank you.
You're welcome. So this gets us 0.0446.
Isn't it a negative?
No, because we're subtracting from 1. It should always be a positive number if we're talking about the areas.
What if, hang on.
Okay.
Oh, I got it. Okay.
All right. Okay. So same thing for B. I want to go look this up on the table on the page before. So when I look up the z-score for negative 0.95, So the area on the chart is 0.1711. And then I want to take this and subtract from 1, which gets me 0.8289. Okay. So number 5 wants me to find the area, and this one is to the left. So if I'm caring about just the area on the left, that's already what the chart gives me. So for A, I want to look up negative 2.2. Which gives 0.0139. And that's the final answer there. For B, I want to look up 1.9. Yep, this one is 0.9713. Questions here? Okay, so the next few problems are going to put these in more context, so instead of seeing straight numbers, it kind of makes a little more sense. Number 6 is telling me if the weights of Oreos in a package are normally distributed with a mean 518 grams and a standard deviation of 4 grams, find the percentage of packages that weigh less than 510 grams. So it tells me my mean, that's my X bar. It tells me my standard deviation, and the specific amount of grams I care about is 510. So I'm going to first start off by plugging this to get my z-score. I wanted to write z equals, not z-score. So I'm going to do the 510 minus the 518 and divide by 4. Which gets me negative 2. So what I want to go do is look up that area on the chart. So I want to go back and look up negative 2. Which gives us 0.0228. And then what I want to do is remember my area is my decimal is my percent as a decimal. So I want to turn this back into a percent. I'm going to take the 0.0228 and multiply by 100. So this one would be just the 2.28%. Oh, I didn't mean to box that. I wanted to say only 2.28%, way less than 510 grams. So if I was going to pick a package of Oreos off the shelf, only 2.28% of those would weigh less than 510. Questions here? All right. So then on the back it says, based on the data in an EPA study released in 2016, the average American generates 1,606 pounds of garbage a year. And let's estimate that the number of pounds generated per person is approximately normally distributed with a standard deviation of 200 pounds. We want to find the probability that a randomly selected person generates for part A between 1,250 and 2,050 pounds of garbage per year, and then B wants more than 2,500 or 2,050. So the first part, I need to go individually find my z-score for the 1,250 and then again for the 2,500. So reading this problem, I know the 1606 is my x bar, that's the average amount of waste. My standard deviation is the 200. And then I'm going to first find it for the 1250. So that's going to be my first x value I'm going to go ahead and plug in. So I have the 1250 minus 1606 divided by 200. And I want to get that z-score. Okay. So this gives us negative 1.78, but if I look back at this chart, my z-scores are out to one decimal place unless they are less than 1. So I am just going to round this to negative 1.8 so I can go ahead and find that on the chart later when I need it for the area. Then I want to go ahead and do the same thing for the 2050. I'm going to do this in red so you can see that this is the other x value I'm using here.
So the answer on the chart of the area represented on the chart it's the direct percentage of data values that fall within that portion of like deviation, right? So that is the probability, like that number.
Yeah.
Okay.
Okay, so this one gets us 2.2. Then what I want to go do is I want to find the areas off the chart. So if I'm looking for my negative 1.8, that area is 0.0359. And if I'm looking for my 2.2, that one on the chart is 0.9861. So because I'm between two data values, I want to go ahead and subtract to find the difference between them. So I'm going to do the 0.9861 minus the 0.0359. Yep, this one is 0.9502. So that is telling me about 95% of all, what is this, Americans? Yeah, Americans generate between those two values of garbage a year. Okay. B wants me to find how many people waste more than 2,050 pounds of garbage a year. So what I want to do is, because more is on the right side of the line, I am going to subtract from 1. And I already found my area for 2,050. I don't know why I want to keep saying 500. But this was the 0.9861. So this is the number I want to subtract here. And this one gives us 0.0139. So a little more than 1% of people use that much garbage or waste that much garbage. Questions on this problem? Okay. Number 8 tells me that AAA reports that the average time it takes to respond to an emergency call is 25 minutes. So that's my X bar. If the this shouldn't say if. The response time is approximately normally distributed and the standard deviation is 4.5 minutes. If 80 calls are randomly selected, approximately how many will have response times less than 17 minutes? So I'm going to not focus on the 80 until the very end, but the 17 minutes is important because that's the data value I care about, because this whole thing was about call length. So first thing I want to do is I want to find that z-score. So I am going to plug into the formula. I have 17 minus 25 divided by 4.5. Okay. So this gives us negative 1.78, like I said before. the chart rounds to 1 decimal place for numbers over 1, so it's going to be negative 1.8. Then what I want to do next is I want to go find the area. So we've rounded to 1.8 because if I look at this chart, there's no negative 1.78, and so I want to be able to find the area. So I just round it to the closest number. So I wanted to find that area. I should have looked at it when I flipped that page. So this is 0.0359. Remember, area is the percent as a decimal. So what I can do is, if I want to figure out how many of the 80 calls are less than 17 minutes, I'm going to take 80 and multiply by that decimal. So this gets me 2.87, which, if I'm talking about number of calls, I want a whole number of calls because you can't exactly have 0.87 of a call. So my final answer here is about 3 calls. Questions on this problem? Okay, so I have a few things to say. First thing I want to say is about today's in-class assignment. Number 3 is like 7 and 8 together. The next thing I wanted to say is we do have class on Wednesday this week. MCC has it as a school day, so I'm not allowed to cancel class. It's also the day that your project is due. It's due at midnight on Wednesday. If you are submitting with, if you have a partner, you both need to submit so I can give you both the feedback. If you have any questions on your project, please email me tonight or tomorrow, because if you email me after class on Wednesday, I probably will not look at it, and so you won't get your questions answered in time. On the project, there is something that asks for, on the rubric, it says it wants you to find the qualitative statistics, I believe. Something worded like that. Anyways, it asks you to find a third one, and there are only 2 you can find based on the number or the types of questions I told you to ask. Let me find out the exact phrasing. It said, yes, it says descriptive statistics for the third question. There is no third question to find it for. And so what I was going to do on that one is I was going to give everyone the full 5 points on that one category because it was my mistake. So you've got 5 points on your project there. I will be publishing the next chapter for this class after tonight's class, so you can go ahead and print out the notes and the assignments for that one. I'll be giving you guys the project next week, so you can look forward to that. And then I also, MCC is releasing their course evaluation surveys for teachers today. So that is out. I am giving extra credit if you fill it out and turn in a screenshot of the completion. I believe when you finish the survey, it gives you a message on the screen that says you've completed it, and then it also sends you an email to your student email address saying you've completed it. Make sure you go ahead and fill those out. That is really helpful to me when I'm looking ahead and planning for the next semester and trying to figure out what I can improve upon. And especially with this year being so crazy and it being online, I can definitely use that to figure out what to improve upon for next semester. So make sure you do the project, the in-class assignment, and then I definitely recommend you go ahead and do that survey.